We're live. We're going to do some experiments. Hello, Y1. All right, let's get started here. We're going to put some universal pH indicator into both of these flasks. All right, here we go. A little bit in the flask on the left. Oh, that one's not stirring, is it? Let's get a little more. Let's get this stirring over here. Come on, baby. There we go. All right. A little bit of flask over here on the left again. The green color you see, that tells us the pH. I'm just using the tap water for my sink. That's pH 7. Yeah, here, we'll show you the pH scale over here. You can check it out. So those are the different colors you're going to see with my universal indicator at different pH values. It's a beautiful green. Yep, looks like my tap water is pH 7. Both sides. And then what we're going to do is we're going to add a little bit of either acid or base to each flask. Just a bit more color over here. And then we're going to roll. Having trouble with my dropper. There we go, baby. Get on in there. Okay. So yeah, these are the different colors you're going to see. Down here, I spilled a little acid on there. That's supposed to look violet. But yeah, we got a nice green color. So we've got pH 7. Hello. I'm in Vietnam. Currently it's nighttime. Sorry about that. Winn-Dixie. All right, let's add, I'm going to add a little bit of acid to this flask over here. The acid I'm adding is hydrochloric acid, also known as HCl. It's the same thing as it's in your stomach. It's just the stuff I add over here is like 100 to 1,000 times more concentrated. Look at that color shift. So as I add the acid, the pH has dropped to 6. Let's keep adding some drops here. Looks like my tap water's got some dissolved substances in it that buffers it a little bit. You can tell. I mean, I'm adding 20% by weight hydrochloric acid, and the color's not shifting much. Someone in Japan, 1 a.m. 1 a.m. You should be asleep, man. I'm never up past 1 a.m. I've added enough acid there. We've got that pH at 3 or below. Yeah, look at that beautiful red color. Looks like Christmas up in here, red and green. Okay, now on the other side, I'm going to add some sodium hydroxide. So we can get a little idea of what the base, adding base to our universal indicator looks like. We'll add a little drop over here. In goes one drop. I love the swirl patterns you can see. Now the base, you can tell, the base that I've added, it's a lot more concentrated. Just one little drop, we get a huge color shift. Looks like we're going to end up maybe, that might look violet, bluish violet, like pH 9. Let's add one more drop, get to the violet, all right? There we go. Yeah, I think that looks good in violet. Okay, so we got a red on one side, a violet on the other. That means we got pH 3 in this flask, 3 or below. We got pH 10 or above in this flask. You can see that from the pH scale here. Is fluoric acid. Picky, I think you mean hydrofluoric acid. Hydrofluoric acid is actually a weak acid. So we distinguish between strong and weak acids in the following way. A strong acid, like hydrochloric acid, HCl, every single one of these that goes into water dissociates, we say, into H+ ions and chloride ions. They all split apart. Hydrofluoric acid is a weak acid, and that means not all of the HF molecules do the same thing. Now what we're going to do is I'm going to add some base to this side. So what we're going to see is sodium hydroxide reacting with the hydrochloric acid that's already there. It'll make salt water, which is neutral. So we're going to neutralize the acid simply by adding some sodium hydroxide. Here we go, baby. We're going to add one drop, see what happens. In it goes. Now you see a flash, look at that rainbow, man. Wasn't that beautiful? You see a flash of a bunch of different colors because, you know, the system needs to equilibrate. But you can tell upon addition of one drop of base, we went from pH 3 to pH 6. That's 3 steps. And because the pH scale works on powers of 10, that's 10 times 10 is 100 times 10 is 1,000. So one drop changed the acidity of this solution by 1,000 times. We're going to add another drop here. Another drop of sodium hydroxide. Here we go, baby. In it goes. One more drop. And of course, as the system equilibrates, you see a bunch of different pH ranges in there, which I think is always beautiful. Looks like we went from about pH 6 to pH 8. 2 steps. So we decreased the acidity by 100 times. So increasing pH is less acidic. Let's add one more drop here. One more drop of base. Actually, it was 2. And we're all the way to pH 10. Now we're going to try the opposite in this flask over here. We're going to be adding some hydrochloric acid, same acids found in your stomach. In it goes. That should neutralize our base. 1 drop there. The acid I use is not as concentrated as the base. We're going to have to probably add a bit more. Here, keep adding the hydrochloric acid. In it goes. You can see that red. You can see the red region there where the acid. It remains in the center of the vortex because just like the eye of a hurricane is low pressure, the center of that vortex is also low pressure, and material tends to stay in a low pressure region. So that the acid that I drip in here, it's going to stay in the middle until it gets pushed down to the bottom, pushed out along the sides. Look at those beautiful color changes that happen. So as I'm adding acid to both of these flasks, the pH should drop and our color should shift to more red. Any reason the 2 glasses are not spinning at the same speed? Yeah, because well, there's a couple things going on. I'm going to go ahead and put them right at the same speed. The stir bars are different sizes. So you'll notice that this vortex is a lot wider. That's because it's got a longer stir bar. This stir bar is a lot smaller, and that's why you've got a thinner vortex here. I'm going to keep adding drops of acid, and that pH is going to drop. We're going to shift toward the red end of the color spectrum. That's the way the universal indicator works. It follows the colors of the rainbow, red being more acidic, and on the violet end, you get more basic. I'm going to start adding acid this side over here. Go like 3, 4 drops. See if we can get that rainbow flash, baby. Come on now. I want to see the rainbow. Nope. We're going to have to try again. Just start adding stuff here, just for the heck of it. Add some drops of base. Add some drops of base. Oh, yeah, we got a nice little rainbow flash over there, huh? Beautiful. Beautiful. All right, put the emoji heart, the emoji heart color in the chat of the color you'd like to see me generate using my acid or base here. I agree there, Picky. Chemistry is beautiful, baby. Chemistry is definitely beautiful. It looks, yeah, I like that there, Picky. Thank you. I'm guessing you put a red heart, so this is for Picky. I am putting in a bunch of drops here, so we get a nice red color, low pH. As I'm adding a lot of hydrochloric acid, that pH should drop. We got a nice red color. pH 3. pH 3, baby. Lots of acid. I'm going to add another squirt. I want to get this color just a little bit better. Just get another squirt in there. Give it a little more cherry redness, huh? All right, Piranha. Piranha's got the first request. We're going for neutral. Neutral's tough to get, man. Let's see if we can do this. So let's see. Haha, black heart. Count G, I can't get black for you. Sorry. Okay, so I want to get this neutral. It's acidic. We got to raise the pH. So I'm going to add base. Hopefully we're going to stop here at green. Green's tough to get. See if we can do it. See if 1 drop does the trick. Street Surfer, 420. You want violet. That's easy. I'm going to give this big shot of base over there. That should go straight to purple for you. That one's easy. I can get you violet. Green for Piranha. You gave me a good challenge here. All right, let's add another drop. See if this does the trick. Aren't those flow patterns cool? Love those flow patterns. Oh, we got a little rainbow flash. Oh, look at that, baby. Come on now. Come on now. Give me green. There you go. Oh, it's going to go to yellow. It's going to go to yellow. We got a little green in there, though. Okay, I'm going to try to add a half drop. This is what we chemists do when we try to add a half drop. What I'm going to do up here at the top, you can watch. I'm going to just touch the dropper to the side, and a little drop's going to come out. You see it? So you can see that little drop I added there. I just touched it to the side. We call that like a half drop. All right, Count G wants me to keep the rainbow going. We're going to try it. Count G, I think I can do it for you. I'll show you how we give that a shot. Look at that up top, huh? Got like blue and gold. So long there, Picky. Thanks for hanging out. I'm still working on green for Pyrana. I think I got you there. Oh, did it again. We started at green, and it went a little bit greenish yellow. JM, sure do. Here we go. Let's add another drop here. Just one little tiny drop. That's probably going to be too much. That's probably going to take us all the way to... Yeah, I overshot. We can add just a drop of acid to pull it back. All right, we're going to try to get the full rainbow. So here's the way I like to do this. We're going to add a bunch of acid over here on the right. All right, just that one tiny little drop. Keep adding acid over here on the right till we get a nice red color. Boy, it's taking a lot. I got you kind of greenish aqua. Thanks there, Rock Bottom. Appreciate you subbing. And I think I do remember, was it about a month ago? Thank you there, Pyrana. Thanks for noticing. I got the green for you. Come on, man. Let's get this nice and red. Boy, my base is really, 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 really strong. Come on now. Pyrana wants orange. Pyrana's challenging me, man. You are making me do the tough colors. Orange is another tough one. Oh, that's beautiful. Yes, Mystic. You can perpetually play as long as I don't put too much of one or the other in. Yeah, when I'm done, I just cover these up and use them again the next round. Come on, Pyrana. I think I got you your orange right there. Your orange. All right, I'm going to add a bunch of acid. Now that I got to the orange, I'm going to add a bunch of acid to get this nice and red. And then we're going to try to get the perpetual rainbow. I'll show you how I do this. I'm going to turn the stir speed off here. All right. And then we're going to add a single drop of base. All right, here we go. It takes a while to develop. You're going to have to be patient. We may have to add more, but we'll see how that works. We'll see how this works. This may give us the effect I'm looking for. We'll play with this over here. I'm going to add a little bit of acid over here. It's gorgeous. So in due course, as I add the acid, the pH drops and it shifts to a more red color. Over here, you can sort of see that base working through the solution. And as the sodium hydroxide over here reacts with the hydrochloric acid, it should neutralize, right? They should neutralize each other. So basically what's going to happen, the purple stuff is going to neutralize the red stuff, and they're both going to pull toward the middle. And in different regions, you'll get different degrees of neutralization, anywhere from 4 to 9, and that's why you see all the different colors. I think I might try adding one more drop. I think we're going to need one more drop. So let's just do this over here. One more drop of base. Okay. Now over here, I'm going to add, this is stirring so everything mixes quickly. What happens if you put tiny things like sprinkles that represent the disease sucked out of a tornado? I mean, I have done that before where we add glitter, which is kind of fun. We could do that if you guys want. We could add some glitter to the tornadoes. Get a little drop there. Another little drop. See if we get a little rainbow flash. You can see that violet working its way down. I think we're going to need one more drop. How about we test some water next? You guys want to test some water? Look at there, baby. Just give me some blue. I saw a little flash of blue. Let's go one more. Oh, we lost the red. We had a Yeah, we're going to need another drop here. There we go. Ooh, look at that just sinking down. That might do the trick over here. We'll see. All right, let's add a bunch of base over here. I'm gonna get this nice and high pH. There, that should do it. That should do it. Okay. Let's add some hydrochloric acid, same acids found in your stomach. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See what we get. Oh, that's beautiful. You like that little flash? Come on now. A little rainbow flash there for you, folks. Look at the gorgeous patterns happening over here, huh? As the acid and base are neutralizing each other. Those colorful swirls. Look at that. That's really pretty. Really nice. Really nice. All right, let's add some base. Yeah, baby. We're getting a rainbow nice today. Thank you there, Jim, JM. Yeah, you wouldn't want to do that, Pyrana. If one of these universal indicator, it's made by a mixture of dyes. So like 4 different dyes. And one of them used to be the active ingredient in X-Lax. So if I drank these, I'm guessing the live would probably emergency end in maybe 10 or 15 minutes. That's right, Street. They do look tasty. Wouldn't it be neat? Yeah, it would be neat if you could kind of make a drink where you could actually drink these. There are some drinks that you can do that with. You can change color, pH gradients with different drinks. All right, let's test some waters. I think we're ready to test some waters. I'm gonna have one more drop of base over here on the. Oh, nice. A healing serum. Excuse me. Healing serum in a video game. Okay, I got this experiment set up for you over here. We're gonna try this. Let me just move real quick. All right. A little bright at first. We are going to test different brands of water for pH, all right? You can count G. You can make it look like that. It's a little tough, but it can be done. So yeah, we're going to test these different brands of water for pH. Let's remind ourselves of the indicator that I'll be adding. I can turn this off. The indicator that I'll be adding is known as universal indicator, also known as rainbow indicator. It displays these colors at different pH values. So pH 3 is acidic, pH 4, 5, and 6 are also acidic, but each step you move up on the pH scale, it gets 10 times less acidic. And then we have neutral green. Aqua is your first indication of base. Then you have blue, which is substantially basic. And then that's supposed to be violet, but I spilled a little acid there, which removed the violet color. pH 10 is very basic. And we will start with some soda water. All right. You did it in middle school. All right, then. Okay there, rock bottom. What's that going to be? Soda water. What's the pH going to be? Let's find out. Rock bottom, put the emoji heart of the color corresponding to the pH that you think this is going to be. Guava Juice YouTuber did this, huh? Here we go. In goes our universal indicator. Get that squirt in there. Ah! We made a mess. We got like a pH of maybe, I'm going to say 3 or 4, yeah? pH 3 or 4, somewhere between red and orange. Yeah, it's like a reddish-orange color. And that red-orange color, it's coming from the carbon dioxide. When carbon dioxide dissolves in water, it makes the water acidic. So that's why we're seeing that. You will have to show me how to make rainbow drinks one day. Okay. I will do there, Count G. Will do, Count G. What we might have to do, some practicing first, but that'll be a good time. Hey, welcome aboard. And Rock Bottom got it right, guessing red. Denzel, thanks for coming aboard. Okay, we're now going to test some Aquafina, this stuff is purified by reverse osmosis. All right. Purified by reverse osmosis, we're going to test to see what this pH is. All right, in goes my universal indicator. Here we go. In it goes. Give that a squirt. And that looks kind of orange, yeah? And you might think, well, my goodness, that water's pure. Why in the world is pure water slightly acidic? It's like a pH of maybe 4 or 5. Yeah, yellow or a bit orange. I agree, rock bottom. What is acid reflux? My teacher is coming to collect my homework. Love it. So the reason why this is slightly acidic is because just like carbonated water, they pump a lot of carbon dioxide into carbonated water. But any water that's exposed to the air will have some carbon dioxide dissolved in it. So when you purify water, unless you can completely keep it sealed from the atmosphere, some carbon dioxide gets in there. Love it there, Denzel. Love it there, Denzel. And no, street surfer, there are no minerals added back for taste in Aquafina. That's an important point, okay, we're going to come back to. But any water that's exposed to the air will have some carbon dioxide dissolved in it, and that will make the water more acidic than it normally would be. So that's why this is not neutral. Now we're going to test Dasani water, which is also purified by reverse osmosis. However, they add some minerals back to this for taste. So in addition to, being purified by reverse osmosis, having some carbon dioxide dissolved in it from the air, they also have some minerals added to it, specifically magnesium sulfate, and that makes it a little more basic. Now we're at pH 6. Yeah? They put additives to make you thirsty too? You got it there, rock bottom. All right. Now we're going to test Fiji, which also, this is just like, I don't know, what does it say? Natural artesian water. So this is not going to be pure water. This is going to be water with some additives in it. And the additives aren't added by, the manufacturer. The additives are added as the water flows through the soil and streams. It picks up dissolved minerals. So let's see if these dissolved minerals are similar to what we'd see in Dasani, if they're a little different. If they're the same, we'll see a yellow color. All right, here we go. Let's do our test. In it goes. And look at that. Just like it says on the bottle, baby. Just like it says on the bottle. It's tough to see, but it says pH 7.2. You got it, man. That is green. Good guess there, Denzel. Good guess. All right, now we're going to test some Icelandic. This one's easy to see. Right there on the bottle, it says pH 8.4. So this also has additives. It's not from the manufacturer. It's just from the source, bottled at the source. I don't know how to say that. Olfus. Olfa Spring, Iceland. I know I'm probably not saying that right. So anyway, let's see what kind of minerals this stuff picks up. Well, if it's pH 8.4, we should expect to see like a bluish or maybe an aqua color. All right, let's see if they're lying to us. Give it a little squirt for the Icelandic. In it goes, and sure enough, we got a beautiful aqua color in the Icelandic water. Pretty, huh? And then finally, we're going to do body armor, which says it's alkaline water because they add a bunch of stuff to make it. Let's see, it says right here, pH 9 plus. pH 9 plus. So let's see what this stuff looks like. All right. Let's give it a shot. See what we get here. And that, sure enough, is like a bluish. Well, actually, that's a purple color, isn't it? I think that's purple. We got the whole rainbow, baby. We got the whole rainbow. With different, isn't that crazy? All these different brands of water. Sparkling water. Thank you there, Caden. I appreciate that. Thank you there, Rock Bottom. Wait, how much to pH testing is the proper color before it's added? It's coloring, is it? I apologize, Denzel. I'm not sure I understand the question. So you're asking how much the indicator adds? The indicator itself is neutral, so it should not affect the pH that much. How much is the highest level for pH? JM, it can be way up there. So very basic solutions, you can get way up there. But generally speaking, most things run on the pH scale somewhere from pH, roughly 0 through 14. 0 is very acidic. So there's our sparkling water that has a lot of carbon dioxide added, so it's going to look kind of red. There's purified Aquafina, no minerals added back, so it's going to be slightly acidic from the small amount of carbon dioxide in the air. Dasani is also purified by, but they have minerals added back that make it a little less acidic than the Aquafina. Fiji has different minerals, making it green. Icelandic has different minerals, making it a bluish color. And then they add some basic electrolytes to body armor to give it that violet color. Now, here's something I'm curious about. I have not been able to figure this out, okay? I do not know why this is the case. Maybe you guys can help me. Thank you there, Rock Bottom. This bottle of water is also purified drinking water. So just like Aquafina, this stuff is purified drinking water, purified by reverse osmosis. You can see the ingredients here are purified water. There are no ingredients added back. So when I see that, I would say, okay, if this is the same thing as Aquafina, I should expect to see the same color. I should expect to see orange. So let's test it. Oh, that's cool there, Caden. What are you studying? Or are you out? I guess you might be out of college, huh? What did you study in college? Or maybe you're still in. I don't know. Here we go. So this is also purified water. And yet it's not orange. I do not understand this. I mean, I'm guessing it could be because either one of these two has to probably have some material leach into it from the bottle. And I'm not sure which it is. And that's the other thing. I'm not sure what kind of like plasticizer would leach into the bottle to cause the shift in pH. What about the water on airplane? Man, that's what's crazy, right? I mean, water isn't water. It's not. None of these are pure water. There's other stuff in there, every single one of them. But nevertheless, it's 99.99999% water. All of them are, right? But there's just a little bit of, I don't know if 99.999 is right, but at least 99.9% water for all of them, right? And those little differences cause this huge difference in the colors with the universal indicator, which I think is really cool. All right, I want to show you something that's been developing over here on our other experiment that we did. It's kind of cool. You might remember that I added universal indicator to this flask over here on the right and just let it set. And what in the heck, right? Let's see. So long there, Rock Bottom. Thanks for joining in. What the heck happened there, huh? Let's spin this up, see what happens. Let's mix everything up. Probably everything's going to turn basic. Science communication, Caden. Awesome. And engineering. That's fantastic. Good to have you along there, Rock Bottom. All right. We'll do some, we'll add some sodium hydroxide to both of these. Let's see what happens. Boop. There we go. Very cool. And then I think what I'll do here, let's add milk of magnesia to this flask over here on the left. Milk of magnesia is a bunch of magnesium hydroxide. All right. So I'm going to add, it's almost all solid magnesium hydroxide and just a little bit of water. It takes a while to get it out. So magnesium hydroxide is a white solid, so you can see it's like all this white goopy stuff. A little bit of water. Let's squirt it in here and see what happens. So it takes a little bit, but some of the magnesium hydroxide will start to dissolve. It takes a while. Let's let it settle down a little bit, but you'll notice it kind of got cloudy now. That's because there's a lot of solid particles of magnesium hydroxide that have dissolved into the water. I said dissolve. I shouldn't have said that. There's a lot of solid magnesium hydroxide that's been dispersed into the water. It hasn't dissolved. They have not dissolved. All right. I'm going to let that, you can see it's like shifting. So a little bit of the magnesium hydroxide dissolves. And when that happens, it shifts to like a blue color. So we know that the magnesium hydroxide, when it dissolves, it is a base. It is a base. Now what I'm going to do is I'm going to add some drops of acid to this stuff over here. Let's talk about the chemistry that's going to happen. So, the magnesium hydroxide will react with the hydrochloric acid that I add, and it will neutralize it. All right? So when I add the first squirt of hydrochloric acid, let me get it in there. You see it shift to red. Of course you do, right? But there's some solid magnesium hydroxide remaining in the flask. I can tell that because it's cloudy. And that magnesium hydroxide slowly reacts with the acid that I added, and it brings it back up to a neutral pH. Isn't that cool? Oh man, JM, I'm loving human anatomy too, man. That's cool stuff. It's all cool as far as I'm concerned. It's all cool. Let's try that again. You can tell it's still a little bit cloudy. And so that cloudiness tells us there's still some magnesium hydroxide in there. I'll add another drop here. One little drop. Let's add another quick drop. Get the red color from the acid. And yeah, that magnesium hydroxide that's in there just totally neutralizes it away. Over here, there's no magnesium hydroxide, so the acid that I add, it just persists, baby. It ain't going away. All right, let's add it to this. I'll add a little more magnesium hydroxide over here on this side. Add a bit more. Here we go. Get it on in there. Give it a dollop. Come on, baby. Get in there. There we go. Nice big dollop. Boy, you can see all those solid chunks, huh? Just swirling around in there. See me get that pH a little higher. Hey, thanks, Count G. Thanks for joining in. We're going to see you soon. All right, let's give this a nice squirt of hydrochloric acid. There's the red color. As the magnesium hydroxide reacts with it, though, it's going to pull it back to yellow. And if we wait long enough, it should get green. If we wait long enough, it'll go all the way to violet, but that takes a while. On the other hand, let's throw some base over here. Beautiful. Beautiful color changes. All right, add some acid. Let that magnesium hydroxide react. Oh, looks like it got a little stoplight action. That's cool. Come on, man. Very interesting. And now we're back to yellow. I can add some acid again as long as there's magnesium hydroxide in there. That should consume the acid. It starts looking red, but you can tell as it's getting less cloudy, there's less magnesium hydroxide in here. And at some point, there won't be much left. Interesting. I'm trying to figure something out here. Can you also do this? Time to say goodbye. Thank you there, JM. Appreciate it. Yeah, I think it's we're about time to shut down the live, I think. So I'm going to flip the camera around, say hi to people like I normally do. If that's not something you want to see, now's your time to, I should just say this is your fair warning. Fair warning. I'm going to flip the camera around and talk to folks here for a bit. If anyone's interested, just see how folks are doing. All right. Let's turn these off. Say hi to everybody. Flip this around. Oh, how are we all doing today? Oh, I should have maybe fixed my hair, huh? Good to hear that, Love Jojo. We had some fun today on YouTube. We did a little acid base experiments. Had a good time. Anyone got any questions about what we did today or any science experiments? Well, I appreciate folks being on live with me today, doing some experiments. Had a good time. Enjoyed them very much. Hopefully I'm going to start doing these every week, so I hope to see some folks around. Enjoyed it. Enjoyed hanging out with y'all, and next time maybe I'll take a shower before I get on a live. What do you think, huh? Make sure my hair's looking okay. All right, folks. Loved hanging out with you. Fun doing experiments as always, and we're going to see you next time. Thanks for hanging out.